Hi guys, my name's Ian and this week I'm back with lesson number 6 in Paul McWhorter's Arduino with Python series. This week we are mostly doing Python and Visual Python. We're building on last week. The hardware is the same, so you'll need to go back and look at last week's lesson if you want to know what the hardware is all about. This week is, as I say, it's all Python, so the Arduino code is the same as last week. So again, if you need that, go back and look at last week. So this week's homework was all about making the virtual meter look great. To be fair, it was probably more of an art project than a coding one, but I had a lot of fun with it. So let's take a quick look at the hardware to show you that it is the same. Make sure we know what we're dealing with. So here we go. As you can see, there's my Arduino Nano with my untidy wiring, and it's already running the code, so we'll look at the code briefly in a moment. So it's streaming numbers in. I can see the blinking light. We are going to be playing with the potentiometer. Ignore this large knob. That is a rotary encoder for an entirely different project I'm working on, so we won't be looking at that at all today. So we will be looking at the potentiometer, the Arduino, feeding into Python, and just to show you that it's working, we will start off my favorite cool term. We'll connect, and there we go, numbers, and they change. Excellent stuff, good to see it working. Now I will disconnect. Most important to disconnect, otherwise it gives Python trouble later on when it wants to connect instead. So there we go. Now let's have a look at Python. You can see my Python is on the left and my Arduino is on the right. The Arduino code is it's unchanged, so we won't be looking at that any further. I will just get it out of the way. Let me do a bit of window management here, and we'll get rid of Arduino, don't need it. So there we have it, the Visual Python, well, Python with Visual Python in it. We'll run through it. I'll call out interesting stuff as we go through it, and before we get too far into it, you will see there are lots and lots of numbers for positioning things all over the screen while I was making my meter look great. I'll not lie to you, most of these numbers were worked out with trial and error. I had great difficulty understanding the axis command in a lot of these things, so I've taken to using the rotate. It's much easier, it can deal with an angle. I also had difficulty understanding things because different objects have different origins. They're not all in the same corner. Some of them are in the center, some are in the bottom corner. And additionally, when you're looking at text compared to a 3D object, 3D text has its orientation is 90 degrees from other objects, so I have to adjust that. So let's start from the top. First thing to call out here is I draw my needle. I've got a blob and a disc in it. I think it looks spiffing. Next thing you'll see is I've from last week I've changed the name of my meter with the volt name. It is now a 3D text object instead of a label. That allows it to rotate and move around nicely when you're twisting the 3D image in the browser. Next bit to call out would be where I'm drawing the major ticks and the units. First thing, look, zip function. Very, very useful and interesting function if you wish to iterate over two ranges simultaneously. You see I've got one going for the counter, the unit counter, and one going for the angle, and then I use those two counters in the small for loop. So just point out the rotate command, it uses angle, and notice also that the angle of the text is being adjusted by 90 degrees. That's pi over 2, and that's to say because the text is already upright when you start with it, so it's already 90 degrees ahead of a 3D object. Next we'll have the minor ticks. Again, I'm using zip, and what I'm doing here is I've decided to display the halfway, the 0.5 marks between the 1 and 2 and the 2 and the 3, etc. And to work out when I'm on a 0.5, I'm using the clever modulus function. So here I'm checking if we are divisible by 5 but not divisible by 10, so I'm on the halfway mark as opposed to I'm on a major tick mark, and then I put in a number 5 again as rotated. I was trying to do these values, the raw values. I'd show the raw counter and the actual digital voltage on my meter as well. I was trying to do those as 3D text objects too, and indeed I was able to display something. That's what this commented out code is about. But I found that the text was then read-only, so it wasn't really very useful. I could display it, but I couldn't change it, so I've had to leave it as labels. Next up, I've got a lot of screws. My little panel, when you will see, is screwed onto a nice metal plate. So I have 4 screws, 1 in each corner. Mine are crosshead screws, so I have had a bit of fun generating the cross on the top of each screw, and basically what it is, it's 2 lines. One is 90 degrees separate from the other. What I've also done is involved a random number so that the screw positions are always a little bit different from each other and always a little bit different every run. Next thing I did, I put a glass cover over the top of it. That's where I was drawing basically another box and playing with the opacity to make it look like a slight glass cover over the top of the meter. Then I've stamped my logo on it. This is my logo, so you will have to get your own. And that logo is going to be displayed. It's displayed in like an arc following the same curve as the meter, so that's why theta is involved. And then I've got a zip again and a letter counter as I jump through each letter, drawing them separately as a 3D text object. Again, having to compensate for text being 90 degrees offset from other objects. And finally, I have my panel that it all sits on, and as I say, it's a metal panel, or rather it looks like metal. Interesting thing to play with is you can specify your own colors and textures. There's a few built into vPython. I found the metal one and I liked it the best. For a while my meter was on a wooden panel, but in the end I decided to stick with this one. So next little bit, connecting to the Arduino. Now you'll see I've changed the code here slightly. I've had to wrap it in a try except, and that was simply because my Arduino connects on COM3. Yours may be different, and I found in fact mine was different when I used a different USB port. It came in as a COM4. I was looking for COM3 and my code fell over royally, so I've wrapped it up in a wee bit of try except to catch the error. And when there is an error, I set a variable to tell me it's not happy. It's the false. I can use that down below, and instead of then reading in the Arduino, I display an error message. And into the code, if the serial's OK here, it reads in what the Arduino's saying, otherwise it flashes the message. Now, let's have a look at this. So if I can go into the demo and then tell this to run, let's see what mine looks like. And it does take a wee bit of time for my thing to warm up with all this going on. And if it would, there we go. At long last, here we are. There we go. How about that? So let's demonstrate it working. And there we go, very nice. Now if we pick it up and twist it around, we can see it's got got like a glass box over it. It's on a panel. There's wee screws there. In fact, if you go around, the screws are coming right through. And if I zoom in, you can see the smaller 5s on the halfway marks, and you can see that my crossheads all look a little bit different from each other. Anyway, that's my effort. I hope you enjoy it, and let's see what Paul gives us for next week. Thank you guys. Bye bye.